The sun. A massive ball of fire, more than 100 times wider than Earth, burning at temperatures that can melt anything we've ever known. But wait, how do we know that? I mean, no one has ever visited the sun, nor even gotten close to it. So how on earth do we know its size, its composition, or even what's happening deep inside it? What if I told you that we've known about the sun's size for centuries, long before satellites, rockets, or space probes, and that today we can even determine its exact elements without ever touching it? Sounds impossible, right? Well, get ready, because what you're about to hear will blow your mind. To understand how we measure the sun, we first need to go back in time. Way back, around 2,200 years ago, a Greek mathematician named Aristarchus of Samos used an ingenious method to measure the distance between Earth and the sun. He observed the angle between the moon and the sun during a half-moon phase and used simple geometry to estimate the sun's distance. His method wasn't perfect, but it was the beginning of something extraordinary. Fast forward to the 17th century, when astronomers like Johannes Kepler and Edmund Halley refined these calculations, using planetary orbits and observations of Venus passing in front of the sun. This gave us a much more accurate measurement of the sun's distance, about 150 million kilometers away. But knowing the distance wasn't enough. How did we figure out the sun's actual size? Once we knew the distance, simple trigonometry helped us calculate its diameter. By measuring the angle at which the sun appears in the sky, astronomers determined that it is about 1.4 million kilometers wide, over 109 times bigger than Earth. But size isn't everything. It's inside the sun. This is where modern science comes in. Ever heard of a spectroscope? It's a device that splits light into different colors, just like a prism does. Every element in the universe absorbs and emits light in specific patterns. By analyzing sunlight, scientists discovered that the sun is mostly made of hydrogen and helium, with traces of other elements like oxygen and carbon. And here's the crazy part. We don't just use this to study the sun. We use it to analyze distant stars, galaxies, and even planets outside our solar system. It's like a cosmic fingerprint that reveals the secrets of the universe. And if you think that's impressive, check this out. Did you know that the sun isn't actually a giant ball of fire? Fire, as we know it, needs oxygen to burn. But there's no oxygen in space. The sun shines because of nuclear fusion, a process where hydrogen atoms smash together at extreme temperatures, creating helium and releasing enormous energy. This is the same process that powers hydrogen bombs. Imagine if we could harness nuclear fusion efficiently here on Earth. It could provide us with unlimited clean energy. Scientists are actually working on this right now. So, let's recap. We calculated the sun's size using geometry, discovered its composition using light, and now we're even trying to replicate its power. Science is amazing, isn't it? And here's a question for you. If we can study the sun from millions of kilometers away, what other cosmic mysteries do you think we'll solve in the future? Let me know in the comments. Also, don't forget to like this video, subscribe for more amazing content, and hit that notification bell so you never miss a mind-blowing science video.